Hi guys, it's Jackie. I'm here again with another Nature Minutes from Nevada Outdoor School. So today I'm going to talk a little bit about astronomy. Did you know that there was a time way back when, way before your parents, your grandparents, your great-great-great-grandparents, that it was believed that the Earth was the center of the universe? I mean, it's not all that crazy to think. I mean, we all want to think that we're the center of attention. We want to think that everything revolves around us. Well, that's actually what people thought. They thought that everything revolved around the Earth, including the sun. But we actually know today that it's the sun that everything in our solar system revolves around. So how did we come across this? So first off, we're going to learn a little bit about how the sun, the earth, and the moon move. And then we're going to figure out what it was Galileo learned. This is an activity to show the sun, the earth, and the moon. So we have those three components and can see how they move in relation to each other. So first off, we have the sun. And we know, so you're not like those people back in the 1500s who think that everything revolves around the earth. We actually know that we revolve around the sun. So we have the sun and we have our earth, and our earth makes an annual revolution around the sun. And so it kind of goes and so that's where we get our year, is that annual journey of the earth around the sun. And where it is in that path, and actually the tilt of the earth, help to make the seasons. So that's our first thing that's happening in our solar system, right? We have the earth making its annual revolution around the sun. Now the moon is tied to us, and the moon, it is constantly making a revolution around the earth. And it's doing this while the earth is revolving around the sun, kind of like this. And it takes about 29.5 days to make a revolution around the earth. It's about 28 days, but then it has to catch up to the earth because the earth is moving at the same time. And so it's 29.5 days for it to make this revolution through its orbit around the earth. And then the last component that I should probably tell you about in how these all move together and how we're able to see the moon and the sun is our rotation. If you can imagine, we're this little white dot, we spin around like this. And so when we're on the side of the earth where it's facing the sun like this, it would be daytime. But when we rotate and spin, some of the time we're not facing the sun and we're facing the rest of outer space, and that would be nighttime because we're not receiving the illumination from the sun at that time. We're on the back side of the earth at that time, and so it's dark, and that would be nighttime. So how do we see the moon, and how does the moon change its shape? Because it doesn't really disappear. It's just that we can't always see the entirety of the moon. The sun is its own light source, and that's why we're able to see the sun. But the moon actually isn't a light source. We're only able to see it because of the reflection of the light that's created from the sun, hits the moon, and bounces back. For example, if you were going to try and reflect light, you would have to have a flashlight over here, right? Like this, in order to reflect the light off of a mirror. If you were looking at the back of the mirror, you couldn't reflect that light because it's behind it. So it's not able to really reflect it and see it. So when we're on Earth, we have to be in a position to see the light that's reflected from the moon. And it's really hard to visualize. So I have this little example behind me. So it's a little bit not to scale. Well, a lot not to scale, because the sun is really, really, really far away from the Earth and the moon. But this will give you an idea. So we have the sun, and the sun is creating light. So the moon is always going to be light on the half that's facing the sun. But the side that's not facing the sun is going to be dark, because what's illuminating it? There's nothing out in outer space that's going to be illuminating it. It's just too far. So it's dark on the back side of the moon all the time. It might have a little bit of a glow because of the light that's being reflected off of the Earth onto the moon, but mostly it's dark. So right here, you can see that the moon is between the Earth and the sun, and because we are in the back of the moon, it looks dark to us, or we actually can't see it. You might be able to see a little bit of glow, and it's at this time, we're actually, if you can see, that would be our daytime that we're able to see the moon. So that's the other thing that makes it difficult to see the moon at this time when it's in this phase. When it's a full moon, the moon is on the opposite side of us, and so we'd be facing darkness, so that would be our night. And the moon is fully illuminated with perspective to us, so that's why we're able to see a full moon when we see the moon in this phase, and so on and so forth. So in these side phases, we're able to see a portion of the moon, but not all of it or none of it, like we are when it's full and when it's new. So phases such as these are how Galileo was actually able to determine that the Earth was not the center of the solar system, but the sun was. He used a telescope similar to this one, obviously not plastic, and with his telescope, he was able to see the phases like these of Venus. And because of how long that cycle took place and the light that was being reflected off of Venus, he was able to determine that Venus and us were both revolving around the sun and not Venus and the sun revolving around us. So go outside, take a look at the stars, have fun.